How's it going, everybody? I wanted to talk about something today called completing the square. It's where we're going to get to a method where we can solve quadratic equations, and that's any equation that has an x squared term in it as the highest term, the highest degree term in a polynomial. And so I'm going to start with some examples. The first thing I'm going to start with is just a reminder. If you've got x plus fifth to the second power, you need to multiply that. You're doing x plus 5 times x plus 5. And you can do that by just the distributive property, basically. So I can take x, and I can distribute it to the x and to the 5 in the other set of parentheses. So when that happens, I get x times x is x squared, x times 5 is 5x. Then I also need to distribute this 5 here. So 5 times x and 5 times 5. So 5 times x is 5x, and then 5 times 5 is 25. So x squared plus 5x plus another 5x plus 25 comes out to be x squared plus 10x plus 25. And there's a pattern here. Whenever I see this thing, x plus 5 squared, and today I'm just going to do examples today and your practice tonight with values where there's nothing in front of the x term, just to kind of keep it easier. When it's like that, there's a nice pattern, because x plus 5, so 5 squared is 25, and then 5 plus 5 is 10. That'll always work when it's just an x and a number like that. There's a nice little pattern. So x squared plus 10x plus 25, it's called a perfect square trinomial. And we're going to use that to solve these equations. So before I solve an equation, I've got another example. This is from your work that you need to do, so I'm actually doing a problem for you. They want you to complete the square on this and then factor the trinomial. So what I want to do is I want to add a number here that will make this into a perfect square trinomial, like this. Well, here's how you do it. You take the number that's multiplied by x and divide it by 2. Why is that? Remember we had 5x and 5x, but this number was 10x, so the number in front of x divided by 2 is that number here. So I'm going to take this negative 14 divided by 2. So step 1, that's negative 7. And then step 2, I'm going to square that. Negative 7 squared is equal to 49. That number I got from step 2, after squaring it, is what I'm going to add here. So now I've got x squared minus 14x plus 49. How do you factor that? Well, if you do the diamond problem, the product is 49. The sum is negative 14. Two numbers that add to negative 14 but multiply to 49. Negative 7 and negative 7 multiply to positive 49, right? So I get, in the end, x minus 7 times x minus 7, or x minus 7 squared. So it's like the first example I did, but backwards. If I square this now, I do this next, I multiply it out, I get all of this, and that's what adding the 49 did, is it made it into this perfect square trinomial, and that's important for solving the equations. So you need to understand that step. That's also in the notes for today's work. There's a little, they put the procedure down for that. Here's number 9 in those problems. For number 9, I want to complete the square to solve the equation. Now I've got this equation, x squared plus 7x equals 30. I want to leave the number on this side and the x's on this side. But these x's can't be combined. You know, you can't combine like terms because they're not like terms. One's an x squared and one's just an x. What I'm going to do is the same thing I did in step 2. I'm going to rewrite this. So I've got x squared plus 7x plus, I'm going to put a box here, plus something equals, I've still got the 30, and I want to add the same thing to both sides. So that box is the thing I'm going to be adding to both sides, and we need to figure out what that is. Well, to figure it out, we do these steps. I'm going to take 7 divided by 2. So here's how I do it. I'm going to go 7 divided by 2, and then I'm going to square it. And when I get that, that's what goes in the box. So what is that? 7 divided by 2 squared? That's 3.5 squared. That's going to be 12 plus 2, 14.5, is that right? I think that's right. You can check my math. So I'm adding 14.5 to both sides of the equation. So now I have a whole new equation. I've got x squared plus 7x plus 14.5 equals 30 plus 14.5 is 44.5. And now the left side of the equation can be factored. How is it going to factor? Well, it's just going to be this x plus 7 over 2. Because it's always half of what this is when you factor it. If you look back at our beginning example, this turned into x squared plus 10x plus 25. Half of 10 is what goes in those parentheses. So we've made this into a perfect square trinomial. What it factors into then is x squared, sorry, not squared, just x plus 7 over 2, or plus 3.5 squared, equals 44.5. Now I need to solve this equation. To do that, I have 2 steps to go. And actually, let me lower this a little bit so I can fit this. There we go. A little bit more space. Sorry, running out. I'm going to take the square root of both sides of the equation. And remember in these, when you take the square root, you get 2 answers, a positive and a negative. I'm going to write them both. So I'm going to get x plus 3.5 equals plus or minus the square root of 44.5. So I did that by taking the square root of both sides there. Square root of 44.5. See, I don't know the answer to that, and I didn't bring a calculator with me, and I'm using my phone to make this video. So the way I'm going to do it is I'm going to write the answer like this. I'm going to subtract 3.5 from both sides. And then I'm going to write my answer as x equals, is this going to make it in the video? X equals negative 3.5 plus or minus the square root of 44.5. Okay, you could get those two answers. I'll let you finish it up. The way you could get them: take the square root of 44.5 with your calculator, add it to negative 3.5, then take the square root of 44.5 again and do negative 3.5 minus that number to get two answers that way. So I'm going to leave you with these ones for today, and then tomorrow I'm going to show you another example kind of like this, and maybe two more examples, so that it hopefully makes more sense by tomorrow. But look at the notes, try the problems, see how far you get, and then I'll try some more tomorrow. Okay? Have a good day.